Hello friends, you are watching Number Collage. In this channel, you will find videos on various mathematical concepts. Today we are discussing JEE MAIN Mathematics paper that took place in the evening shift on 24th of January 2025. In this question, equation of ellipse is given and midpoint of the chord is given, and from this we have to find equation of this chord. We know that equation of the chord of the ellipse whose midpoint is x1 y1 is given by t equals s1, where t is x1 upon a square plus y1 upon b square equals 1, and s1 equals x1 square upon a square plus y1 square upon b square equals 1. So using t equals s1, we write x into 3 upon 25 plus y into 1 upon 16 equals 3 square upon 25 plus 1 square upon 16. This becomes 48x plus 25y upon 25 into 16 equals 144 plus 25 upon 25 into 16. This gives 48x plus 25y equals 169. Hence, the answer option is 1. In this question, this function is defined for this real domain and this codomain. We will divide numerator and denominator by 2 raised to minus x. So it becomes 2 raised to 2x minus 1 upon 2 raised to 2x plus 1. This we write 4 raised to x plus 1 minus 2 upon 4 raised to x plus 1. 1 minus 2 upon 4 raised to x plus 1. Now for f of minus infinity, this will be 2 upon 4 raised to infinity plus 1. 1 minus 2 upon 1 minus 1. And f of infinity, this will be 1 minus 2 upon 4 raised to infinity plus 1. 1 minus 0. We find that this function is continuously increasing minus 1 to 1. So it is increasing, hence 1 1. Secondly, range minus 1 to 1 is not equal to codomain minus infinity to 1, which implies it is not onto. So the correct answer option is 1, 1, 1, but not onto. In this question, we have to find the value of this expression where alpha greater than beta greater than gamma are positive. In the first step, we will simplify the expression. That will be cot inverse alpha beta plus 1 upon alpha minus beta plus cot inverse of beta gamma plus 1 upon beta minus gamma plus cot inverse of alpha gamma plus 1 upon gamma minus alpha. Here alpha minus beta is positive because alpha is greater than beta. So we can write this as tan inverse of alpha minus beta upon 1 plus alpha beta plus, in the second case also, this beta minus gamma is positive because here beta is greater than gamma. So we can write tan inverse of beta minus gamma upon 1 plus beta gamma. Here in the third case, gamma minus alpha is negative because gamma is smaller than alpha. So the term here will change and become pi plus tan inverse of gamma minus alpha upon 1 plus gamma alpha. This we write tan inverse alpha minus tan inverse beta plus tan inverse beta minus tan inverse gamma plus pi plus tan inverse gamma minus tan inverse alpha. Cancelling tan inverse alpha, tan inverse beta and tan inverse gamma, we are left with just pi. Hence, the correct answer option is 4 pi. In this question, position vectors of vertices of a triangle are given, from which we can find position vector of its centroid. That will be adding the position vectors of the vertices and dividing this sum by 3. That gives p bar plus q bar plus r bar upon 3. Next we are given position vectors of the orthocenter p bar plus q bar plus r bar upon 4 and that of circumcenter alpha p bar plus beta q bar plus gamma r bar and hence we have to find the value of alpha plus 2 beta plus 5 gamma. We know that the orthocenter H, the centroid G, and the circumcenter are collinear for an acute angled triangle, and centroid divides segment HC in the ratio 2:1. So by section formula for internal division, we have position vector of G equals 2 times position vector of C plus 1 times position vector of H upon 2 plus 1. Let's wipe this, putting the values. Cancelling these three, we write 8 into alpha p bar plus beta q bar plus gamma r bar plus p bar plus q bar plus r bar upon 4. 4p bar plus 4q bar plus 4r bar equals 8 alpha plus 1 p bar plus 8 beta plus 1 q bar plus 8 gamma plus 1 r bar. Equating coefficients of the like vectors, 8 alpha plus 1 equals 4 gives alpha equals 3 upon 8. 8 beta plus 1 equals 4 gives beta equals 3 upon 8, and 8 gamma plus 1 giving gamma equals 3 upon 8. Now the value of alpha plus 2 beta plus 5 gamma will be 3 upon 8 plus 6 upon 8 plus 15 upon 8, 24 upon 8, 3. Hence the required value is 3. The correct answer option is 1, 3. In this question, M denotes number of points where this function in the domain -2 to 3 open interval is not continuous, and N denotes where it is not differentiable, and hence we have to find M plus N. Domain of the given function is -2 to 3, excluding -2 and 3. Now points of discontinuity M will be the function is not continuous, that means the points where this greatest integer function is breaking, and such points are -1, 0, 1 and 2, even though at this point 2 mod x minus 2 is continuous. So together for these two functions there will be 4 points where this function is not continuous. Next we find n, the number of points where this function f of x is not differentiable. As we know, the function is not differentiable where it is not continuous. So these points will be -1, 0, 1 and 2 for this greatest integer function mod x. The function is also not differentiable at sharp points, which for this mod x minus 2 is a sharp point here at 2, which is already included in this set. The number of points at which the function is not differentiable is also 4. So M plus N will be 4 plus 4, 8. Hence the correct answer option is 3, 8. In this question, the sides of the triangle are represented by the lines x plus y equals 11, this line, x plus 2y equals 16, this line, and 2x plus 3y equals 29, this line. Line x plus y equals 11 can be drawn by putting first y equals 0 to get x equals 11, and then by putting x equals 0 to get y equals 11. So by joining this 11, 0 and this 0, 11, we can draw this line x plus y equals 11. Similarly, we can draw lines x plus 2y equals 16 and 2x plus 3y equals 29 as shown in the figure. After having drawn the lines, the triangle in question is shown in the figure by red boundaries. It is given that point 11 upon 2 comma alpha lie on or inside this triangle, which means the line x equals 11 upon 2, which is parallel to the y-axis. This line cuts this triangle in 2 points, alpha minimum and alpha maximum, this point and this point here. Alpha minimum, which is y, can be obtained by putting x equals 11 upon 2 in this first equation. So that gives 11 upon 2 plus y equals 11 gives y equals 11 upon 2. So alpha minimum here is 11 upon 2. Now to find alpha maximum, that is y, we will substitute x equals 11 upon 2 in the third equation. That will be 2 into 11 upon 2 plus 3y equals 29. 3y equals 29 minus 11, 18. Y equals 6. So we get alpha maximum 6. Now we have to find the product of the smallest and the largest values of alpha. So alpha minimum into alpha maximum is 11 upon 2 into 6, 33. Hence the correct answer option here is 3, 33. There is a small correction here. The line 2x plus 3y equals 29 is not this one but this one. So please note this. In this question, S40 and S12 is given and we have to find out S30 minus S10. So for an AP, we have S40 is 40 upon 2, 20 into 2a plus n minus 1, that is 40 minus 1, 39d, which is 1030, and S12 is 12 upon 2, 6 into 2a plus n minus 1, that is 12 minus 1, 11d, which equals 57, which becomes 4a plus 78d equals 103, and 4a plus 22d equals 19. Subtracting 56d equals 84, d equals 84 upon 56, 28 2s are 28 3s are, d equals 3 upon 2. 4a plus 22 into 3 upon 2 equals 19. 4a equals 19 minus 33 minus 14. A equals minus 14 upon 4 minus 7 upon 2. Now S30 minus S10 will be 15 into 2a plus 29d minus 5 into 2a plus 9d. 30a minus 10a plus 435d minus 45d. 20a plus 390d. 20 into minus 7 upon 2 plus 390 into 3 upon 2 minus 70 plus 585, that will be 515. So the correct answer option here is 2, 515. In this question, an infinite series in terms of alpha is given and we have to find the value of alpha. By certain manipulations, we can convert this series into a geometric series. For that, first we write the series as it is. We will divide throughout by 7. So 7 upon 7 equals 5 upon 7 plus 1 upon 7 square, 5 plus alpha, plus 1 upon 7 cube, 5 plus 2 alpha, plus so and so forth up to infinity. We will subtract this new series from the original series 1. Changing the signs, 7 minus 1, 6 equals, we write this 5 as it is, plus 5 upon 7 minus 5 upon 7 will be 0. So this will be alpha upon 7 plus 5 upon 7 square minus 5 upon 7 square will be 0. 2 alpha minus alpha, alpha upon 7 square plus 5 upon 7 cube minus 5 upon 7 cube is 0. 3 alpha minus 2 alpha is alpha. So this will be alpha upon 7 cube plus so and so forth. So this is 1 equals alpha upon 7 plus alpha upon 7 square plus alpha upon 7 cube plus so and so forth up to infinity. So series on the right hand side is a GP with first term alpha upon 7 and common ratio 1 upon 7. So 1 equals sum of this geometric series, which is a upon 1 minus r, that is alpha upon 7 upon 1 minus 1 upon 7, alpha upon 6, that gives alpha equals 6. So the correct answer option is 3, 6. This system of equations has infinitely many solutions. Here lambda and mu are unknowns and we have to find value of lambda plus mu. we will solve this question in a different way. These are equations in 3 variables. We will eliminate variable x and convert them into system of equations in 2 variables and then apply the condition of infinitely many solutions. So for that, first we will multiply this first equation by 14 and then subtract from this third equation. So third equation and then first equation, changing the signs, minus 25y plus mu plus 42z equals 5. We name this 4. Then we multiply second equation by 7 and subtract it from this third equation. So the third equation first, then the second equation, changing the signs, 3 minus 7 lambda into y plus mu minus 35 into z equals minus 2. We name this 5. Now for infinitely many solutions, we have a1 upon a2, that is 3 minus 7 lambda upon minus 25 equals b1 upon b2 mu minus 35 upon mu plus 42 equals c1 upon c2 minus 2 upon 5. By cross multiplication, 15 minus 35 lambda equals 50 gives lambda equals minus 1, and again by cross multiplication, 5 mu minus 175 equals minus 2 mu minus 84 gives mu equals 13. Now we have to find lambda plus mu minus 1 plus 13, 12. Hence the correct answer option here is 4, 12. In this question, A is coefficient of 30th term and B coefficient of 12th term, and further it is given 2a equals 5b. We have tr plus 1 equals 2n minus 1 cr into x raised to r. So we write this as 2 times 2n minus 1 c29 equals 5 times 2n minus 1 c11. This we write as 2 times 2n minus 1 factorial upon 2n minus 1 minus 29 2n minus 30 factorial into 29 factorial equals 5 times again 2n minus 1 factorial upon 2n minus 1 minus 11 2n minus 12 factorial into 11 factorial. This will get cancelled. This we write as 2n minus 12 factorial upon 2n minus 30 factorial equals 5 upon 2 into 29 factorial upon 11 factorial. This we write 2n minus 12 into 2n minus 13 into 2n minus 14 into so and so forth 2n minus 29 into 2n minus 30 factorial upon 2n minus 30 factorial, which equals 5 upon 2 into 29 into 28 into 27 into so and so forth 13 into 12 into 11 factorial upon 11 factorial. 2n minus 30 factorial cancels, 11 factorial cancels, 2 ones are 2, 6 are 12. So the right hand side becomes 5 6 are 30 into 29 into 28 into so and so forth 13. Now comparing the left hand side and the right hand side, we can equate the smallest quantities, which are 2n minus 29 on the left hand side and 13 on the right hand side. So 2n minus 29 equals 13, 2n equals 42, n equals 21. Hence the correct answer option is 2, 21. In this question, vector a bar, vector b bar and vector c bar are given, and we have to find projection of vector c bar minus 2j cap on a bar. First we will find b bar, which is a bar cross I cap minus 2k cap, which is determinant I cap j cap k cap 3 minus 1 2 1 0 minus 2, solving which we will get b bar equals 2 I cap plus 8 j cap plus k cap. Now c bar is b bar cross k cap, so c bar will be 2 times I cap cross k cap plus 8 times j cap cross k cap plus k cap cross k cap. 2 times I cap cross k cap is minus j cap plus 8 times I cap plus 0. So C bar is 8 I cap minus 2 j cap. Now we want C bar minus 2 j cap. 8 I cap minus 2 j cap minus 2 j cap will be 8 I cap minus 4 j cap. We have to find projection of C bar minus 2 j cap on A bar. That will be C bar minus 2 j cap dot A bar upon mod A bar. 8 I cap minus 4 j cap into 3 I cap minus j cap plus 2 k cap upon square root of 9 plus 1 plus 4. That will be 24 plus 4 plus 0 upon root 14. 28 upon root 14. Cancelling root 14. We get this projection 2 root 14. Hence, the correct answer option is 3 2 root 14. In this question, function f of x is given in the form of a determinant where a and b are constants and x not equal to 0. We have to take limit of f of x as x tends to 0, that is limit of this determinant. As we know, when we take limit of a determinant, we have to take limit of each of the elements of the determinant. Therefore, limit of this first element as x tends to 0 will be a plus 1, because limit sin x upon x as x tends to 0 is 1. Similarly, limit of this element will also be 1 plus 1, 2, and limit of this third element will be b plus 1. Limits of the remaining elements being same as the element itself. We will simplify the determinant by carrying out r1 minus r3 and r2 minus r3. So the limit becomes determinant 1, 0, minus 1, 0, 1, minus 1, a, 1, b plus 1. Evaluating 1 into b plus 1 plus 1 minus 1 into 0 minus a. This will be a plus b plus 2. But this limit is given to be lambda plus mu a plus nu b. That gives mu equals 1, lambda equals 2, and nu equals 1. So we can evaluate the required value. Lambda plus mu plus nu whole square equals 2 plus 1 plus 1 whole square. 4 square 16. Hence the correct answer option is 4, 16. In this question, there are two groups. Group A consists of 7 boys and 3 girls, and Group B consists of 6 boys and 5 girls. We have to find the number of ways in which 4 boys and 4 girls, that means total 8 members, can be invited for a picnic if 5 of them must be from Group A and the remaining 3 from Group B. So out of 8 members, 5 members must be from Group A and the remaining 3 from Group B. Let us consider different cases. We will start from maximum to minimum. So in case 1, we take 4 boys and 1 girl from Group A and 0 girls and 3 boys from Group B, making it 8 in total. In case 2nd, we will take 3 boys and 2 girls from Group A, 1 boy and 2 girls from Group B, making it 8. In third case, we will take 2 boys and 3 girls from Group A and 2 boys and 1 girl from Group B. In Group 4, if at all we have to take 4 girls, but there are only 3 girls available in Group A, so we cannot consider the fourth case. Now we will calculate combinations from each group. For case 1, 4 boys from 7 boys, 7C4, into 1 girl from 3 girls, 3C1, into from 6 boys, 0 boy. Here there should be B instead of G. So 6C0 into from 5 girls, 3 girls. This should be G instead of B. 5C3. This will be 7 into 6 into 5 upon 3 into 2 into 3 into 1 into 5 into 4 upon 2, because 5C3 is same as 5C2. Cancelling 6. So this will be 35 into 30, 1050. Similarly, for the second case, 7C3 into 3C2 into 6c1 into 5c2 will be 7c3 is 7 into 6 into 5 upon 3 into 2. 3c2 is 3 into 6c1 is 6 into 5c2 is 5 into 4 upon 2. This works out to be 6300. In third case, the combinations will be 7c2 into 3c3 into 6c2 into 5c1. That will be 7c2 is 7 into 6 upon 2. 3c3 is 1. 6c2 is 6 into 5 upon 2. And 5c1 5. This works out to be 1575. Now we will add 1050, 6300 and 1575. That add up to 8925. Hence, the number of ways in which group of 8 can be invited is 8925. Hence, the correct answer option is 3, 8925. In this question, we have to find area of the region enclosed by the curves y equals e raised to x. This curve y equals mod e raised to x minus 1. This curve and y-axis, this one. The curve y equals mod e raised to x minus 1 will be either plus e raised to x minus 1, which is to the right of the y-axis, this part of the curve, and it will also be y equals minus e raised to x minus 1, that is 1 minus e raised to x, this part of the curve, which will be to the left of the y-axis as shown. And the required area that we have to find out is this area which is marked here. Before that, we have to find the coordinates of this point of intersection, say P. For that, we will solve curves e raised to x and 1 minus e raised to x simultaneously by equating them. That gives 2 e raised to x equals 1, e raised to x equals half. So that gives x equals ln half or minus ln 2. So the coordinates of point P will be minus ln 2 comma 0, this point here. Now the required area, integral e raised to x minus 1 minus e raised to x dx from minus ln 2 to origin, that is 0, integral of 2 e raised to x minus 1 dx 2 e raised to x minus x from minus ln to 0, 2 e raised to 0 minus 0 minus 2 e raised to minus ln 2 minus of minus ln 2. That will be 2 minus 2 upon e raised to ln 2 plus ln 2, which is 2 minus 2 upon e raised to ln 2 is 2 minus ln 2, which is 1 minus ln 2. So 1 minus ln 2 is going to be the required area. Hence, the correct answer option here is 4, 1 minus ln 2. In this question, we have to find the number of real solutions of the equation x square plus 3x plus 2, this parabola, and minimum of mod x minus 3, which emerges at 3 here with positive part x minus 3 here and negative part minus x minus 3 here, comma mod x plus 2, which emerges at minus 2 here, its positive part is x plus 2 here and its negative part minus x plus 2 here. Parabola x square plus 3x plus 2 has two zeros, minus 1 and minus 2. Minus 2 is already shown here. Another 0 is here, this point. And putting x equals 0, we get y equals 2, which is this point here, this one. Now the minimum of mod x plus 2 is from here to here, and then from here to here, and then going up here. Now to find the number of real solutions of the given equation, we have to find the point of intersections of the parabola x square plus 3x plus 2 and the graph of minimum values of mod x minus 3 and mod x plus 2. This parabola is seen to cut graph of minus x plus 2 at minus 2 comma 0 here and the graph of minimum x plus 2 at 0 comma 2 here. This shows the number of real solutions of this equation will be 2. Hence, the correct answer option here is 1, 2. In this question, A is a square matrix of order 2 with entries either 0 or 1, which means if A is A, B, C, D matrix, then elements A, B, C, D will either be 0 or 1. Let E be the event that A is an invertible matrix, which means determinant of A is not equal to 0, which also means AD not equal to BC. And in this case, we have to find the probability P of E. First, we will find out the total number of matrices that will be formed. 2 raised to 4, 16. The matrix is given to be invertible. In that case, AD will not be equal to BC. But instead, for convenience, we will consider cases in which AD equals BC, which means they are not invertible. And this is possible if AD equals BC equals 1 each, or AD equals BC equals 0 each. The number of cases when A equals B equals C equals D will be only one case, and if AD equals BC equals 0, there will be following three cases. For AD, it will be 0 0 or 0 1 or 1 0, and for BC, three cases 0 0 or 0 1 or 1 0. So total cases for non-invertible matrices will be 3 square plus this one case, 10 cases. Hence, number of cases for invertible matrices will be total minus 10, 6. Hence, probability of event E will be favorable cases 6 upon total number of cases 16, 3 upon 8. Hence, the correct answer option is 4, 3 upon 8. In this question, we are given this differential equation, and if y of pi by 3 equals 0, then we have to find value of this expression. We will divide throughout by this 2 cos x. So dy by dx equals sin 2x is 2 sin x cos x upon 2 cos x minus 4 sin x upon 2 cos x into y. Cancelling 2 cos x, we get dy by dx plus 2 tan x into y equals sin x, which is a linear differential equation. For solving this, we have to find integrating factor e raised to integral 2 tan x dx, e raised to minus 2 times integral minus sin x upon cos x dx. This will be minus 2 log cos x, which will be e raised to log sec square x, sec square x. So the integrating factor here is sec square x. Now the solution, y into integrating factor sec square x equals integral of integrating factor sec square x into this sin x dx, integral sin x upon cos x into cos x dx, integral sec x tan x dx, sec x plus c, which is the general solution of this differential equation. Now it is given y of pi by 3 equals 0, which means y equals 0 when x equals pi by 3. So 0 equals sec pi by 3 plus c, 2 plus c, that gives c equals minus 2. So the particular solution becomes y sec square x equals sec x minus 2. That gives y equals, dividing by sec square x, cos x minus 2 cos square x. We will wipe this part. Now we will find y of pi by 4, cos pi by 4 minus 2 cos square pi by 4, 1 upon root 2 minus 2, 1 upon 2, y of pi by 4, 1 upon root 2 minus 1. Next, we have to find y dash of pi by 4. That will be minus sine of pi by 4 minus 4 cos pi by 4 minus sine pi by 4 minus 1 upon root 2 plus 4 times 1 upon root 2 into 1 upon root 2. That will be minus 1 upon root 2 plus 2. Finally, the required value y dash of pi by 4 plus y of pi by 4 equals minus 1 upon root 2 plus 2 plus 1 upon root 2 minus 1, which gives 1. So the answer here is 1. In this question, we are given value of this integration in terms of alpha and beta, which are constants, and hence we have to find value of alpha plus 2 beta. For this, we have to solve this integration. This type of integrals are solved by expressing the numerator 2x square plus 5x plus 9 as constant a times term in the denominator x square plus x plus 1 plus another constant b into derivative of x square plus x plus 1 2x plus 1 plus constant of integration c. In the right hand side, ax square plus a plus 2b into x plus a plus b plus c. Now we will compare the like terms of the left hand side and right hand side. So we will get a equals 2, a plus 2b equals 5, and a plus b plus c equals 9. From the second equation, 2 plus 2b equals 5 gives b equals 3 upon 2, and this third equation 2 plus 3 upon 2 plus c equals 9 gives c equals 9 minus 7 upon 2, c equals 11 upon 2. Now we will use these three values in this expression, which becomes 2 times x square plus x plus 1 plus 3 upon 2 times x plus 1 plus 11 upon 2. We will wipe the upper part and write the integral. So the given integral becomes 2 integral x square plus x plus 1 upon square root of x square plus x plus 1 dx plus 3 upon 2 integral to x plus 1 upon square root of x square plus x plus 1 plus 11 upon 2 integral 1 upon square root x square plus x plus 1 dx. This is 2 integral square root of x square plus x plus 1 dx plus rest of the integrals remaining the same, which equals 2 integral square root of x plus half square plus root 3 upon 2 square dx plus 3 upon 2 integral plus 11 upon 2 integral dx upon square root x square plus x plus 1. Let's swipe this. Equals 2 times x plus half upon 2 square root x square plus x plus 1 plus 3 upon 8 ln x plus half plus square root x square plus x plus 1 plus 3 square root of x square plus x plus 1 plus 11 upon 2 ln x plus half plus square root x square plus x plus 1 plus c. Alpha can be obtained by cancelling these two and then adding this half and this 3, giving 7 upon 2, and beta can be obtained by cancelling this 8 and writing 4, 3 upon 4 plus this 11 upon 2, 25 upon 4. So the required value alpha plus 2 beta will be 7 upon 2 plus 25 upon 4, 32 upon 2, 16. So alpha plus 2 beta is 16. If you like this video, please like, share and subscribe this channel. Thank you.